Okay, can you like explain that and how that's a little bit different from kind of the normal approach to how we are usually taught, especially in like an applied science program?
More theory and less concrete.
Okay, no, that's exactly right. So like more theory and less concrete. So what does that mean? Well, oh, hey, everyone. Sorry, your first name was
Jacob.
Jacob.
My last name's Powell.
Powell. Oh, okay. I thought your last name was Jacob. So I was like,
Oh, no,
meet
my bad.
Jacobs. You know, sorry. Anyway,
Just like Lake Powell, except I'm Jake Powell.
are you going to be teaching other courses?
Yeah, I'm also going to be teaching foundations.
Oh, cool. Okay. All right. Well, hey, everyone. Round of applause for joining the new faculty.
Powerful.
He's not going to last. No, just kidding. What?
So with like having this understanding of like how people learn or how systems evolve or are created, I think in the context of learning, it helps us understand that there's not just one way to learn where it's just like, this is how we've always done it, this is the way it has to be done, but understanding that maybe I learn differently, maybe someone else learns differently, and you can actually enhance that person's ability to learn, not only learn information,
if I
but
could shake my
be able
head
to
harder.
understand it by understanding how they process and then making that learning environment tailored to that.
Yes.
And so you have a lot of different students have a lot of different
Yes.
preferences for how they learn.
Yes.
And so for you, that information is valuable to how can I tailor my class to be flexible? And then as a student, it'd be how can I take notes? How can I learn how to recall this information in a way that is useful for me? For software development, it could be applied to how my user is going to do this, or countless things.
Absolutely. I feel like and what I'm saying here is not only is it my responsibility to learn about my students and create a curriculum and a course content and a pedagogy, great word, that is inclusive of all learning styles and types, but it's also your responsibility, to adapt to me as well. How many agree or just disagree with that? How many is it just like fully just my responsibility to make sure you learn? Oh, you are you're like new. Yeah, I like that. It's bigger.
I mean, to some extent, yeah, it's obviously a give and take relationship, but I feel like to some extent, if you're forcing the teacher to change so dramatically, I mean, regardless, no matter what the teacher does, you still have a choice whether or not you're going to learn anything, right?
Absolutely.
You can show up. You can decide whether or not to show up. You can decide whether or not to pay attention.
Yes.
You can decide whether or not to do your homework. Like that is so totally out of the instructor's
Yes.
control. And then there's also the idea of like, yeah, everybody learns differently, but if you always expect people to adapt to the way that you learn, how do you expect to be able to teach yourself anything?
Yes.
And I feel at that point, like, you failed as a student because you can't figure out how to learn from different people.
Because like ultimately, like I think my point is we all have a responsibility to be understood and to understand. Okay, and I think when it comes to like understanding these frameworks, the very first principle, concept, like root foundation that we learn is that like human beings are human beings because human beings have learned to adapt. I found this really cool research that shows how the Neanderthal discovered how to kill pain through pain relievers, and like they became extinct like 200 years later. Fun fact. So
Correlation or causation?
and it's like, what exactly are we talking? Are we talking like they discovered, like Valerian root, or anyway? Okay, so this idea of like concepts, though, of frameworks. When we look at just a really quick review of applied physics versus theoretical physics, or applied mathematics versus theoretical mathematics. Okay, so most of what you learn in college is like, apply this formula and get this, like, do this task, right? And we call this, again, remember, linear models, linear learning, linear environments. What would a nonlinear environment or a nonlinear model be? Let me swipe up for you to give you a hint. Okay, it's learning in these models and frameworks. And why is this so important? And I was just talking to Peter Aldis on the way to class here. He teaches the compiler course, and he was telling me just how much students are struggling to think in terms of concepts and frameworks. That it seems like all the way up until they get to his class to do the compiler, they've learned, these applied linear, equations, but when it comes to understanding, like a lens to evaluate complex issues, like putting together a compiler. Which, by the way, does anyone even know what that means? Like, what a compiler? Okay, and like, why that would be so difficult to put together, okay? I think we've talked about here, like, the difference between a high-level language and a low-level language, and how these, these IDEs are basically just programs that write programs and convert everything to machine language and then binary, and like, in more or less words. So like, the reason is like, well, I think I showed you a little bit last week of how, like, when you take like audio data, of how like you hear like the wave vibrates your eardrum, which converts it to like electromagnetic frequency, which breaks it down into, at its final, like, when it actually gets stored in your short-term memory, like, what that is represented as, if you could actually see what it looks like, it's much more complex than like a bunch of ones and zeros, okay? And so the reason that this is important to understand is the concept of conversion of these very complex, incomprehensible data stimuli that gets input. When it comes to human beings, we have so many different ways of interpreting, okay, all this complex data. And sometimes, most of the time, in fact, I would say every time, there's errors in our information processing. Have you ever, like, wondered why, like, a perfectly, like, what appears to be perfectly running, a program that appears to be running perfectly, when you look at the error report, has so many errors, but, like, it looked fine. Have you ever wondered about that? Like, is there ever a time where there's not errors? Do you know what I'm talking about when I say that? Like, any of you who have been involved in testing will look at these reports and realize that there is this constant process of correcting and recorrecting. And usually, okay, here's a good way to put it in human terms. think of like you answering a question at a spelling bee, okay? They ask you the question, you give the answer, but you kind of stumble a little bit and stutter. Your voice cracks, and at first you think of a completely different wrong word, but you catch yourself, and then you give the right answer. Technically, you gave the right answer, but was it a 100% efficient, smooth process to get you there? Do you see what I mean? Does that make sense? Like, computing is the same way, okay? So, frameworks, information processing. Complex systems. What is the whole concept of complex systems? Do you think we could say it in 3 sentences? Come on, I'm counting on you. You're my go-to.
So free agents act in a certain way.
Nice.
And as they work together, emergent properties arise from that cooperation. And then that creates a greater system, a complex system.
Excellent. That was a great way to say it. Okay, yes. So when we talk about agents, right, or like a multi-agent system or a multi-agent adaptive system, can you kind of put together what that means in your head? Okay, so the concept of an unpredictable agent, which is any individual that has some semblance of like agency, and to be able to put multiple agents into some sort of like sphere to evaluate in a scientific way, where you have a control, you have a hypothesis and a framework, and to be able to predict what these multi-agents are going to do with billions of variables. You would say it's impossible from a scientific sense, at least from a reductivist scientific sense. But from a complexity framework, okay, this is first and foremost understanding that like all complex systems, this is the grand fundamental principle of all complex systems, is fundamentally wired to do what? That is true. Self-organized to do what? Optimize. So what do we do to optimize? Automate. Oh, yeah, you guys. That's why I said this class doesn't work for me. This is like a celebration. Okay? Automate. And we automate by doing what? Like, why do we automate? What happens when we learn to automate tasks at a lower level so that we can do what at a higher level? You said it. Self-organize, which enables us to operate at a higher degree of efficiency, yes, but there's a specific word that's kind of similar to this.
Abstraction?
Autonomy?
Ooh, good. Autonomy. What's autonomy mean?
You can act on your own. You can act on your own.
Okay, yes, it's a capacity to be a free agent. And we talk about degrees of autonomy. So it's this constant concept of, we talk it in the mental models of heuristics and schemas, which these are these mental models that we are constantly downloading information to, so we can just operate without having to think about it. That's what the brain wants to do. Okay, it's just like I want to be able to like go to the bathroom in the pitch dark night and like not miss a beat. And I mean that in every sense of the word. Okay, so like what does that mean then? Why? Why do we want to do this? We want to automate these lower tasks so it can free up.
Our energy for more complex tasks.
Yes. Okay. And, okay, now I'm going to just accelerate it, and we're going to go to the job market. We're just skipping through that second framework. We talked about cognitive functions enough. Okay? So, all right, what does that mean for the industry when we talk about AI in the job market?
Well, we are automating things. We're making AI be able to do the simpler things so we can go on to do more complex things. Like AI isn't going to take over everything. It's just going to take over the easy stuff as we get into more complex stuff.
Okay. I literally could not have said it better myself. Mostly because I would have gotten in a tangent 2 words in. But you just plowed right through. Kudos to you. So the idea is okay, the history of development, the history of evolution, the history of technology dictates that we will find ways to automate so that we can free up more of our energy to create and innovate autonomously. And what does that look like exactly? Well, think of the word processor. For those of us who are in their elderly years, I'm going to get a call from HR one of these days, he's constantly making fun of people's age. So, do you remember having... True. Do you remember having to write things up on a typewriter?
No.
I do.
I always had a computer. My dad was a CS guy. We always had a computer. But I did have
Is your
to
dad
know-
Neil Harrison?
Yeah.
I think I remember running into you in a class one time. You're we made that connection somehow. Anyway.
Yeah.
No! I genuinely get sad when I lose any one of you. Yes.
I'll be back, I promise.
Okay. It secretly offends me and saddens me when people are just on their computer and I act like I don't care, but I care.
You're teaching ECS course. How are people not going to be on there?
It's true. I know. I'm a man of consent. If you want to listen, listen. If you don't, at least show up. Makes me feel like a big man. So the idea is typewriters. Okay, I used to have to go to a library and look up those little index cards and go pick out books and struggle right, and then feed the paper.
We discovered bags.
Then we automated this whole thing called carrying units. Okay, and so but that's not even the hardest part. You had to write out a rough draft. Then you had to write out an outline, then a rough draft. Then you take it to your dad, and he's marks it all up because you missed a semicolon there, your grammar's off there, you should have capitalized there. Okay.
Then word process.
Then we did this whole crazy thing called word processing. And what did that do? Do you realize there were entire industries dedicated to word processing skills? The highest paid position at a newspaper was an editor. Okay? So when we look at things like the calculator or the printing press or whatever you want to evaluate, it becomes very obvious then that when it comes to human creation, human content, we are fundamentally driven and motivated to not have to worry about syntax and logic errors and all those annoying things that really made up an entire industry, right, of programming, so that we can do what, right? innovate and create cool stuff. We could be more autonomous. We could work within these systems more autonomously. So when I say I